Good afternoon, ladies and gentlemen. It's a great pleasure to be here, and thank you, David, for inviting me to this. Okay, so it's the HPTLC, and the question that we want to address here is who we are. That is the HPTLC Association. You have probably not heard about this organization, so I want to spend a few slides on that, and then I'm going to explain to you what is HPTLC and what I understand under the term. And then a few things on HPTLC in QC of herbal drugs, then TLC or HPTLC and the African Herbal Pharmacopoeia, and then HPTLC for Africa. So let's start with this. So the International Association for the Advancement of High-Performance Thin Layer Chromatography, or in short, the HPTLC Association, is an international non-commercial, non-profit association according to Swiss law. We were founded in 2012 in Switzerland, just after a conference, by 15 scientists from 7 countries. So these are the founding countries of our organization. And by now we have more than 130 members from 18 countries in 6 continents. So we have divided up in local chapters so that we can serve our members better. So we have local chapters. And so there's one in Australia, so there's one in China, one in India, one in Indonesia, one the newly independent states, so the former USSR. Then we have North America, we have Thailand, and we have the United Kingdom. So you can see there's a large green spot here in Africa, and I hope this presentation creates some interest in HPTLC, and maybe one or the other a member of the audience will be interested in joining us and help to achieve our goals. So this is our board, the board of directors, and we have also non-voting members of the board and a scientific secretary. If you are interested in finding out more, you can go to our website, which is on the next slide, and you can actually check this all out. So what does the association do? Our mission and goals. So we want to promote the use of HPTLC in various fields, particularly with the fields of botanicals, of course. We do want to bring together HPTLC users from different walks of life. So we want academia, industry, research, and regulatory and standard setting bodies all talking to each other about it. We want to contribute to an improvement of quality, particularly in herbal medicines and herbal dietary food supplements. Then we want to be a worldwide leading resource for HPTLC information. For that, we have also educational tools on our website. We want to develop and validate methods. We want to establish and maintain the International Atlas of HPTLC. And we want to support pharmacopoeias. And there's finally to publish educational material. So that comes together with this one on the lower right corner here. So if you have more interest in this, please check our website. So let's come to TLC, right? So this is what most of you consider TLC, and that's what I consider TLC. But when I come back to David's introduction, talking about the whatever $16 billion business of the legal marijuana, I would think legal cannabis is probably better, legal hemp or whatever. This won't get us into that. Because, you know, we are used to looking at something like this and say, well, this is the standard, this is our reference, and that's about the same, right? All these things are the same, even though this moves down here. And then what about this here, right? So this is probably likely this here, and then this is all this, and this is, so now is this that, and is that, and is this the same as this? And if anybody tries to reproduce what we are seeing here on the screen, you might get another version of the same. So is not really an analytical technique fit for purpose. When we talk about HPTLC, this is how it's looked like. So you see all these different standards, they are all at a different position. And they will always be at the same position, no matter how often and where you're going to reproduce that. And of course, then you have a fingerprint here in which you can try to identify any of this. So this, as you can see, is quite a difference. And this on the right side certainly will get us into the cannabis business. Right, so when you compare HPTLC and TLC, they are both forms of planar chromatography with all the pros and cons. But for the TLC, it's the simplicity and the low cost. Right. But then this is what you get in return. On the other hand, the HPTLC focuses on reproducibility and separation power. So reproducibility is the goal here, right? We have a highly standardized methodology and optimized parameters. And on the TLC side, we can do what we want. So everybody does that. And then how do we want to set standards? Here, everything is very much defined. We have well-defined standards. We have no flexibility for a validated method. So you do what you're told, and then you're doing this and you're getting the expected results. So at the end, we are having a reliable analytical endpoint, okay? Analytical results that you can use in court. On the other side, you have some trial, I do some TLC, yeah, it's good. And then I do my HPLC or my UPLCMS to prove that, well, yeah. So why are we wasting our time with this here? That's the first question. At the HPTLC level, we have traceable digital images, or we have scan data. They are all qualified by a system suitability test on each plate. And this is completely compliant with CGMP. Well, this sounds like a lot of money, but it actually turns out to be quite simple. Okay, so when we look at the plate format here, we have a standard plate. This is 20 by 10 HPTLC. On the TLC side, we have everything possible. And then we have instrumentation. This is where the money comes from, right? So in TLC, there's nothing. You can use a pickle jar, a little capillary tube, and you just spot it on and they look under UV. Good. This here on the other side is a little bit more expensive, but it's not what we are going to talk about here. We're not going to talk about equipment. We're talking about concepts. So let's move on. This is what we want to achieve: reliable analytical endpoints. Okay, so in one way, you can look at HPTLC as the miniaturized form of TLC. So we have an optimized TLC method that requires a 20 by 20 plate and not an 8 by 8 by 5 or whatever cutoff. And this needs to be done under standardized condition. Then this is what you get. If you transfer this to an HPTLC, you get exactly the same. Okay, so you can scale that actually down. And the difference between this and this is the HPTLC has finer column. So this is the same thing as going from an HPLC column to a UPLC column. Shorter columns, faster analysis, better separation. Okay, so when you scale this down, you see actually the TLC and the HPTLC look the same. They are the same. So the HPTLC can be looked at as miniaturized TLC, but only if this part is done properly, which is rarely. Okay, so in return for this miniaturization, you have less solvent, shorter and developing times, and more samples per plate. So this is what your improvement is going to be. HPTLC is some sets official already in many pharmacopoeias. So when you look at the USB, for example, there is the chapter 203. It has been revised in May of last year again. So this is most updated. It's the HPTLC procedure for ID identification of articles of botanical origins. And here is what you need to have, right? So it says, this is the HPTLC plate here. If you find particles, it has a UV indicator. Okay. And then you have a device suitable for application of indicated volumes as bands. It doesn't say you need to buy equipment. You can use a ruler and you can use a small capillary. You just have to make sure that you put the right amount at the right position, always at the same position. Okay, then you need to have a device suitable for controlling the activity of the stationary phase by preconditioning the plate to a prescribed relative humidity. Well, you can buy fancy equipment, but you can also do a desiccator that has magnesium chloride saturated solution in there. And you put the plate in there, and then this is it. Then you need to have a suitable chromatographic chamber to maintain reproducible vapor phase composition to allow and so on. So a twin trough chamber, $80, that's all you need. Okay, so then a device suitable for reproducibly drying the developed plate. Okay, so you can use a hair dryer that you position at 40 centimeters in front of your plate in the hood at a stand, and then you turn it on, 5 minutes later you turn it off. So that's reproducible drying in this context. Okay, then you need a device for suitable treatment of the plate with reagent. Well, you need to use a dipping device or can use a sprayer if you like. Okay, then a device suitable for controlled plate heating, a plate heater with a temperature. Good. And then you need to have a device that gives you shortwave and longwave UV and a photographic system for documentation of the chromatogram. And you can use a smartphone. So now anybody tell me HPTLC costs any money, all right? So we can discuss that. Of course, on the other hand, you have everything else that you can buy, and then you push the button and the machine does it for you, and then it's a convenience article. But the essence here costs no money, and that's why I want to talk to you about HPTLC and no longer TLC. Okay, so HPTLC in a nutshell means we have a standardized procedure where we use that plate. Then we apply 15 tracks, 8 millimeter from the lower edge of the plate, 8 millimeter from the left, 8 millimeter bands, 8 millimeter from the lower edge of the plate, and the first track comes at 20 millimeters. So then we condition to a relative humidity of 33%. Then we develop the plate to 70 millimeter from the lower edge in a saturated chamber. Saturation takes place with filter paper 20 minutes prior to insertion of the plate, and the solvent level is 5 millimeter. And only by doing this, and this is just a convention, only by doing this, you will get reproducible data everywhere, every day. So from a regulatory point of view, HPTLC is a concept. No special equipment is necessary. So now, I show you the other end of the thing. So what you can do is you have samples like, say, ginkgo, and then you put those samples into a chromatographic process. You put them on the plate, right? And then there's some magic being done. And at the end, you have the analysis. And this is what the plate looks like. Okay, you have different detection modes prior to derivatization or after derivatization. All of this is available from one plate, just different illumination modes. You need a UV lamp for that, of course, and you need some reagent to put this on, but that's all. Okay, so then we can drive this a step further. We can talk about comprehensive HPTLC fingerprinting. So the plates that we have used for identification of samples, they have information that goes beyond identity. And that information is of quantitative nature because all those pictures here, with the click of a mouse, you can convert into profiles that look like this. Or you can use, if you have a little bit more interest in this, you can buy a densitometer and you can do this at different wavelengths. But if we don't talk about this here, just this, the image, everybody can do with a smartphone, and this, there's plenty of software that you can do that. All right, so now all of this information is combined in an analysis file, and that analysis file is something that is secure, can be made secure. And then you can go to the bank with this and discuss what you find. Okay, so all of this comes in this analysis file. All right, so now how we use this technology and this approach for quality control of further drugs. First of all, HPTLC is now part of all pharmacopoeia and monographs on plants. They may not call it, but let's say if it's not HP, then it's at least TLC. So there is no pharmacopoeia that doesn't have TLC. Most of them have HPTLC. So the US FDA, which is responsible for licensing all the stuff that we have heard about in the previous talk, they enforce the USP Chapter 203 for identification. So if anybody uses TLC, that's what they're going to do. And if they are going to file for application for registration, they should provide some HPTLC that follows that chapter. Okay. So the entire botanical industry worldwide is using, let's say HP, but TLC. The Europeans and the Americans, they're all using HPTLC. Also, the Chinese are using HPTLC. The Indians, if you go to the literature, primary literature, there are hundreds of papers published by Indian companies, by Indian researchers, just focusing on HPTLC. So this is a big thing, and it's not something new. You may not have heard about this, but you have people in South Africa that even do it, and they publish beautiful books on the subject. Okay, so it's used for identification. It is used for detection of adulteration. It's used to detect minimum content of marker, and you can use it for the assay of markers. So most of the things that we have heard in the previous discussion can be done by HPTLC. So let me show you some examples. So this is something that is now in the United States Pharmacopoeia in a kind of different way. We have several monographs, but they have one thing in common. This is caffeine. So there's cola, there's coffee, there's mate, there's tea, there's guarana. And you see, when you look at different detection modes, you can discriminate these species quite nicely. They all have some distinguishing features, and you will always be able to see if one is reproduced or is mixed into the other. Then up here, at the same time, you're seeing that this is a common zone. All of these different drugs contain caffeine, right? So now we can look at this here and can make some quantitative assessments. Okay, so we can just make a dilution of this sample so it is within a linear range, and then we can use image evaluation, or we can use scanning densitometry. And then you get out of the picture, for example, you get a calibration curve here for caffeine, and then you can use that to detect how much caffeine is actually in the seed powder, or how much of caffeine in this is extract. We had the example just before, so we have those 4 alkaloids, and they are defined with minimum content, so it's very easy. Let me switch one more time back to this here. So when you look at this here, this, for example, is used as caffeine. Now, it's not the marker, but this is the caffeine peak here, right? So we can put a marker side by side to this that has a certain intensity. That's a reference standard of caffeine of a defined amount. And the zone here must be of at least that intensity. That will be the minimum content. All right, so this is what we are seeing then in this respect. So we can do a quantification, or we can do a limit test. So then we say anything that is above this limit is good or is bad. In this case, it's all bad because this is decaffeinated extract. And that means the acceptable limit of caffeine has to be below 0.1%. So this is our reference point, is the limit test, and all of these things here, they are above. If we don't detect it, it's below, so these samples will pass. And just think about this, we don't have to do another analysis here. We're doing the identification as it is prescribed by any pharmacopoeia. You must do HPTLC for identification period. So while you're doing it, you put the marker of caffeine at the same plate, at the right level, and then you see whether your zone is more intense or not. And then you have met that limit test as well. Here's a little bit more involved example. Here we look at the QC of ginkgo products. So ginkgo is a big seller everywhere in the world, and there's a lot of money in ginkgo because anybody is scared to lose a brain, and so this is brain food. So what you do with the ginkgo, you convert this into profiles, right? This is comprehensive HPTLC fingerprinting. Again, we have 3 different detection modes. We get the profiles here, and then we can look at this here. And anything that's not supposed to be here will help us to identify things, for example, buckwheat, so far fruit, so far flower, so far bud, rutin and quercetin, because quercetin is quite cheap, rutin is quite cheap, and all of these ginkgo products are standardized to contain certain total flavonoids, which are then hydrolyzed to form quercetin, so it's easy to put the quercetin before and everything will pass. Now you see, out of all of those products of the market, just a few are good. The most time you see there's a big yellow zone, this is quercetin. So this is above the allowed limit. So this is good quercetin level. So this is too much. So all of these things have either added quercetin, or they have sophora or other natural materials added into. And then you see here, there are some green zones here. This is all coming from sophora. The ginkgo doesn't have that. Or they have a fat rutin zone here, which is not supposed to be here. And you do this all during the identification. You must do your identification. Then you put some limit for quercetin, some limit for rutin, and you see exactly whether there is adulteration or not. And then in this case, the rutin zone, this one here, will be just out of proportion, just by looking at it. If you want data, well, you do this and then you get a report. Okay, so now, where do we get these methods from? The European and the United States Pharmacopoeia, also the British Pharmacopoeia, are starting now to introduce HPTLC, and they are not really showing you images. So the HPTLC Association, this is our website, by the way, here, so just stop here. And then if you add everything, then this is the website. We have an atlas for numerous plants, and we are trying to look at what's out in the world, right? So this is an example here of ginger. That's our entry for ginger. We start by looking at multiple pharmacopoeias and what they do in TLC. So we have numerous pharmacopoeias, as you can see here. This file is also part of the website then. Different pharmacopoeias have different approaches, different specification. You see that ginger always looks, well, somewhat similar, somewhat different. And then we figure out which is the one that we like best. And this is called the Atlas method. And this is happened to be the one that we have in the United States pharmacopoeia. So this is our method of choice. And then we also provide synonyms and common names of the drug. And we put a list of the evaluated methods up there. And then the heart of the matter is actually this here. So we are going to show multiple samples from different origins. And this is all good ginger. And now we are addressing the real issue. Plants are naturally variable. And if we know more at some point in time, whether these things have been properly dried or whether they have been dried in the oven or in the sun or whatever, different age, different. So then we see similarities and differences. And this is just facts. This is not a standard, but a regulatory authority or an industrial user can use that and say, well, this is what I would like to do. I would like to find something, raw material that looks like this. And we don't want this here because we don't like this. Okay, so we want this here. Or we want only a sample that has this. This one would fail because it's kind of unique. And we still don't really know what causes it, but that's life. We don't have to accept any of this. We can accept all of it. This is a tool to compare multiple samples from different batches over a different period of time, just to see what is ginger, right? So, well, this is all ginger. We are sure of this. Now, if it's not ginger, but some related species, all of a sudden we see, well, you know, there are some related species in the same family, and they are quite different. And then you can add multiple detection and you get even more differentiation. So it's really easy because they are all kind of gingers. They're all used in cooking. So it's ginger. So you find all of this stuff on the market. And as soon as there is a demand, people are getting very creative and putting adulterant things in. And it must make economic sense to put something instead in. So this technique can really tell you what you're looking for and what you're not looking for. Okay, so now we come to the African herbal pharmacopoeia. So this is what it is. Actually, the African herbal pharmacopoeia has tried in its first volume a very, very unique concept, and it's not bad at all. All drugs are analyzed with this same set of solvents. So there's always 3 analyses, and these are the solvent systems that they are using. And then, so it's 1, 2, 3 solvents, and then we have different detection modes. So they have 250, 235, don't know how they do that, but well, let's see, it's, well, anyway, so a 254 source probably, whatever. So ultraviolet light, and then we have a vanillin, and we have anisaldehyde spray reagent. My question, of course, will be, how are we going to reproduce that? All right, so for me, the first thing to do is to transfer this to HPTLC and see what it looks like. And this is what we then get. Okay, so this is the same. Oh, sorry, that's the same in HPTLC. So we have 2 sets here. There's a methanolic extract and acetone extract. Because they have chosen to use acetone, I personally think methanol is better, but that's up to discussion. And so we have the 3 different systems. And then we see, well, I mean, at least, you know, you have something to see, you to discuss, you see zones, and they are straight lines, right? And it's not like blurbs here. Okay, good. I was approached by the committee or the responsible people of the African herbal pharmacopoeia. Shall we work together? And I said, yes, of course we want to. So we have been debating for a long time how to deal with this. So there are 2 different options here. We can either go and have a dedicated method for each plant. So this is myrrh, for example, and that here, that was myrrh, by the way, as well. So this is myrrh. Okay. So this would be the HPTLC version of a good method for myrrh, dedicated to myrrh, and you see all the different resins here. So they are quite distinguishing. Now, the other thing is, I still like the 3 solvent concept here, but I don't like the benzene, I don't like the chloroform because they're toxic and we don't want to poison ourselves by dealing with this. So we need to get rid of those. And then the issue with the ammonia is that, well, it's very difficult to standardize. It loses the gas upon standing, and it's always Okay, so we came up with 3 different alternatives here. So this is what you see down here. And now you can actually see, yeah, well, we are seeing some zones, and we have also added multiple detection. There's 254, 366, and then anise aldehyde and 366 and white light. So we have one system, a second system, and a third one, and they can be made complementary. So I think that is a valuable discussion. We have to decide whether we're going this way or we're going this way. Now, last point, HPTLC for Africa. We had a diploma thesis from the University of Geneva, and I forgot to put the reference in here. So I'm sorry, I need to actually put the paper that was behind that in there. And the idea was to look at African plants, and Burkina Faso was the country of origin here. And we looked at Sclerocaria birea. And this is how the plant looks like. We had different parts of the plant and different origins, and that's quite consistent. That methodology was then used to look at some samples that were on the market, the plants in powder, in a capsule, or extracts in a capsule, or tablets. And this is an ideal method to quality control this. But we also wanted to see what else we can do here. And then you see on this side, it's a little busy slide, but when you get a copy of this, and then you can actually see. So there are about 30 other species that have been investigated with the same method. This is just a general method for flavonoids in multiple detections. And you see all of these different things, they are different, right? So this is Sclerocaria birea, and all of them have some flavonoids, and they can be discriminated. So it's one set of conditions, one method to do all of this, right? For each of them, of course, you have to identify a marker and do it more quantitatively. So this is the approach that we are also offering. We should consider this also for the African herbal pharmacopoeia, to do something like this. Few methods, broadly applicable, or general methods, or individual methods. And then finally, we now need to come back to the money issue, right? So not everybody has the ability of buying expensive and fully automated equipment. Well, we don't have to. The first thing is we have to agree on suitable standards. So for example, this is our reference. That can go in a pharmacopoeia, that can be in an atlas, that can be published anywhere. So this is publicly available, and the methodology that goes with it. And then we need to agree on the SOP. So we should not discuss whether or not we want to do HPTLC, because HPTLC is just an agreement on the procedure, right? So there is an SOP, you do this, you do this, you do this. This costs no money. This is just a matter of being persistent and agreeing to what we have said. So we have the reference. We know how this reference was made just following this SOP. So when we use this SOP, we can then make a transfer to the different labs, right? And we can make that transfer down to the level that is available. So if we transfer this atlas or pharmacopoeia method to a government lab that has all the fancy equipment, we expect them to do exactly the same. If a company is making money in the billion-dollar hemp business, well, they will have money to invest and do good chromatography, right? If people don't have that money, they might do some manual things. They still can afford a twin trough chamber and some capillaries and a ruler and a smartphone. And even if they can't do this, they can go even further down. They can do TLC. Here, this is what you see. This is the automated HPTLC, fully equipped with reference material. That's the one where we're doing manual application and manual tank, right? And then we can go even further. We just do it the simplest way. But we are following the same procedure, and you see this one here, you can still correlate with this. But if we think we put something like this in the pharmacopoeia, or what we have in the African herbal pharmacopoeia, I don't want to be negative about this. This is just an assessment of the situation. When you take what's in the African herbal pharmacopoeia right now as the reference point, or if you take any of the other monographs that you find on the internet, nobody discusses the methodology behind, and that's why these things here, they become not very reproducible. But if we take a professional standard as the reference, then even with simple equipment, you can make a relation to this and do simple quality control. And the more you want to do, the more you can add. This is my message for today. And just to, when I walk out here, this is just what you need to do. If you want to analyze a sample, you have to go through all of these steps. And the simpler you get them, the more manual work will be involved. The more machines you get for this, the easier it's going to be. But altogether, this is a very, very simple technique that gives you a lot of information all at the same time. Thank you very much for your attention.
Yeah, thank you very much. Very interesting there. And yeah, you've converted me from being a TLC fan to an HPTLC fan. And that takes a lot of doing. I'm a very traditional man, but thank you for that. You know, there's the other opportunity, just going back to cannabis. And I like cannabis because it's very artisanal. You know, it's one farmer here, one farmer there. People who actually don't know anything about standardization or the industry. And I've actually ended up with samples of people in Lesotho saying, can you test this thing for us? Can you test that thing for us? So I think there's a great opportunity to have a kind of HPTLC or TLC on the fly, you know, for farmers to just test their stuff before they send it to these big expensive labs. So do we have some of that kind of technology, Ike, which you can just use in the field? Because I saw something there that you showed us.
Well, there are some professional solutions. I don't know what it's called. It's not ToxiLab. There's some commercial thing that it's a box that you can use to test some pharmaceutical substances.
Okay.
If you want to do very simple TLC, you just need a glass tank, you need to have a capillary, you need to have a ruler, and you need to have some chemicals. I mean, you cannot do it in the field. You need to go into a garage or something.
Yeah, that's what I mean. So, I mean, yeah, in the field.
So that is possible. And
okay.
You know.
Yeah. So it looks like.
But yeah. the point is, if you want to do it on the fly, you still need to have a point of reference, and for that, I think you need to have those good standards, because you can compare to those.
Yeah. No, so it's great. I'm also happy. I'm also excited about other, initiatives locally in South Africa. There's an Atlas coming, and we will bring that group here to also talk about some of their work, because it's all complementary. Our focus is really Africa-wide, not just one country. Okay, maybe not there. Anyway, so the next speaker is Denzel Phillips.